Hello guys, I hope you're fine. Today we are going to talk about the Lagrange mean value theorem. The words Lagrange, I think it's the name of a scientist, okay? And mean value theorem, you may have studied many times these mean value theorems and numerical analysis, I think calculus, okay? So mean value theorem, but right now we are just talking about the real analysis and we are just studying this mean value theorem and real analysis, okay? So let f of x be a function such that f of x is continuous on a b and differentiable on a b. So okay, there exists at least one value c belong to a b such that f dash of c f of b minus f of minus f of b minus f of c, sorry, minus f of a divided by b minus a. So from here you can see that we are just supposed to uh, prove this one, okay? So we are just they're just required that you are supposed to just prove these things, that f dash of c of b minus f of a divided by b minus a, okay? And f of x is continuous on a b, and f of x is differentiable on a b. So we are going toward the proof. So given that f of x is continuous on a b and differentiable on a b, okay? So you can see, okay, right now it is too clear. To prove this, uh, let f of x a f of x plus b of x, we just took this from ourselves, so as to prove these things, we took this from ourselves, we consider it from ourselves, okay? So from here you can see it is just a polynomial, you can see clearly it is a polynomial because it is a coefficient. You can see from here it is a variable, so it is a polynomial, and here a and b are two suitable chosen numbers such that f of a equal to f of b, okay? So we consider it from ourselves, so as to prove these things. For this, we suppose we consider this from ourselves, okay? And from here we can say that f of a equal to f of b, okay? So now I have divided the whole question into three equal parts, into three steps, so as to make it easier for you. Step 1, and the step 1, we will just talk about the continuity. As for the question, f of x is continuous on ab, as they have told us in the question that f of x is continuous on ab, you saw from here, from there, and the question is I told you that let I am again showing you. From here you can see f of x is continuous on ab, f of x is differentiable on ab. So here again I have written that now as for the question, f of x is continuous on ab, okay? So a f of x is also continuous on ab because it is a polynomial. B of x is also continuous, so their sum would be also continuous. So very easy. If this is continuous, it means this would be also continuous, and this would be also continuous, so their sum would also be continuous, okay? We know that f of x plus b of x is polynomial, and we know if polynomial is continuous, then their sum is also continuous, so this is continuous on a b. Very easy. Now step 2. In step 2 we will just talk about the differentiability, okay? So now f of x is differentiable on ab, as they have told us in the question that f of x is differentiable on ab. So f of x, we just took the derivative of this one, okay? So from here you can see, as I have taken the derivative of this, so it will become like this. From here you can see f dash of x is also differentiable because it gives us a very finite, a very mean very clearly and very finite value. So it means that it has a finite value and it is differentiable on ab. So and f dash of x is a finite value on ab. So it also proved. Now and the step 3, we will as we have considered that f of a equal to f of b. So in our first step, as we have considered f of a equal to f of b. From here you can see, as we have considered it from ourselves, so as to prove this thing, for this we have taken it from ourselves, okay? So again I have written f of a equal to f of b. So as we see f of x plus b of x, so we can see that equation satisfy the condition of the Rolle's theorem. This equation satisfy the condition of the Rolle's theorem. You may have studied the Rolle's theorem. So And the Rolle's theorem, we are taking the derivative of that equation, and then we are taking we are considering something from ourselves, and we are putting that things in that equation. So the same we will do here. Over here you can see this equation. I took the derivative of this one, then I suppose uh, we can find c belong to ab such that f dash of c equal to 0. So when I put x instead of c instead of x, when I put x over there, then I got f dash of c a f dash of c plus b. Just I put x instead of just I put c instead of x. So from here you can see, and as I have considered that f dash of c must be equal to 0, so I'll make it 0. So after making this 0, it will become like this. So f dash of c plus b, so it will become f dash of c equal to minus b divided by a. Easily you can take it from here, easily, very easy. Okay, now it's clear. So now we are going again towards f of a equal to f of b. So this is the equation that we have considered from ourselves. We will just put a instead of x and b instead of x. So from here you can see, as I put a instead of x, I put a in the place of x, and I put b in the place of x. So from here f of a equal to f of b, so we will make also this is equal to each other. So from here you can see this is equal to this one, this is equal to this one, because this is equal to this one. So from here, as I shift this to this side and shift b to this side, finally I got b divided by a. Easily you can get from here b divided by a. Then I took sorry, I shift f b to this side and f a to this side. Easily just minus b plus f of a divided by b minus a equal to b divided by a. So now what I will take, I will just take minus 1 as a common from the above one. As I took minus 1 as a common from the above one, I got this one, I got these things. Minus 1 f of b minus 1 f of a divided by b minus a. Take minus 1 common from above, so both side multiplying by minus 1, I will get minus b divided by a. Okay, from here you can see f of dash of c equal to minus b divided by a. So I just taken minus a so as to make the equation mean comparable to this one. For the sake of that, I just take the minus as a common, and now you can see it's equal minus b divided by is equal f dash of c. So I'll write f dash of c instead of this one. So this is the final proof of this theorem. Okay, you can see from here. So now I'm going to solve an example by using this theorem. So in the second video I will solve an example because it will become so long. So then okay, so this video becomes so long, then that's why I will solve an example by using this theorem. Okay, Allah Hafiz.